Okay, we're going to start Chapter 3, Electronic Structure and Periodic Law. In this, we're going to cover 3.1 in your book and 3.2. The first thing that I need you to do is take out your periodic table, and I want you to pause the video and I want you to color it and add all the numbers and all the symbols and everything they've got on this one. So pause the video, get out your coloring crayons, and it works best with coloring crayons because you can shade it light. You don't want it shaded so dark that you can't see the numbers because we're still going to be using the numbers. You can also use colored pencils. That works really well too. Okay, so we need to know what the rows are. The rows are known as periods or shells out from the nucleus. That is the numbers that we added over here. Those are our shells. They're also, anytime we added numbers, that represents our shells. Now up here, where the numbers are, these right up here, let's see that yellow arrow, these are numbers up here represent a column. And the column are our families or our groups. And sometimes the yellow and the red area have referred to as 1A or 2A for the yellow columns, and then starting with the B in the red column, 3A, 4A, 5A, 6A, 7A, 8A being helium's column. And then the blue area is sometimes called the B columns or the transition metals. So the main groups are the yellow and the red, and they're the A's, and the transition is the center, and it's the blue. But on your test, you'll still have the numbers up at top, the 1 through 18. That's the way it's heading, so just so you know. Okay, so this represents an atom, and as we look at the center, we've got the nucleus. And then coming out from the nucleus, we have shells. And the shells are what we wrote as periods on our periodic table. Now the first one out would be the first shell, the second one out would be the second shell, the third one out would be the third shell. So that represents how far out from the nucleus we can find things. So as we're looking at the atom, the periodic table can tell us where we are, how many shells out from the nucleus, by looking at what row we're on. Okay, so when we look at the periodic table, we have different subshells. Those are the colors that we colored. And the first one we colored yellow, and that yellow area is what we call the S shell. And I tried to draw for you a sphere. That's what that little ball thing was supposed to be up by it. And I put by it that it has a 1. That's one orbit that it has. It has one orbit. It can hold 2 electrons. Every orbit can hold 2 electrons. So that's the yellow. And remember, it's S. It's one orbit. It holds 2 electrons. The red area, the color group that we colored red, that's known as the P subshell. And it has 3 different shapes that it can be in. It can be in the PX, which is this along the x-axis. It can be in the PY, which is the same shape along the y-axis. And it can be in the PZ, which is along the z-axis. Okay, it looks like basically 2 balloons hooked together. That's empty in the center, and just like the sphere up here would be empty in the center, that skin is where you would find the electrons. Now, notice by P I had 3. It can have 3 orbits. The 3 orbits are PX, PY, and PZ, and it can hold 6 electrons. Electrons can be 2 in an orbit. Okay. In the blue area, I had D equals 5. The D is basically a cloverleaf pattern for 4 of the orbits, and for the 5th one it looks like the P a little bit, but it has like a donut around the center, and it looks a little bit like that. Okay, sort of funky looking. So this one has 5 orbits, and it can hold 10 electrons. Now on the F, which is the green, I didn't show you here the shape of it because they've got lots of funky ones. All you need to know is it has 7 orbits and it can hold 14 electrons. Okay, so we're going to use the periodic table and use our group numbers, which are along the top, our family numbers, and our period numbers, which are also our shell numbers, which are on the side here, down that we've put in over here. And we're going to be able to find any element that we want. Say that I wanted group 13, so here's group 13, and I wanted it in period 5. So I just come down to period 5 and I would get indium. If I wanted period 6 and I wanted to go over to group 9, I would come over to where group 9 and period 6 matched and I would get iridium. So very quickly I should be able to find any element by looking at the group number and the period number. This reminds me a lot of Battleship, if you remember Battleship. Okay, when we did our light lab, we actually were putting energy in to a compound. And when we did that, the electrons actually jumped up a layer, or jumped up a shell. And as they were emitted back down, as they were given off energy and falling back down, we actually saw light given off. Okay, within the visible spectrum. This arrangement of atoms that we've got with the periodic table right now was actually put together by several different scientists, and we probably need to know a little bit about each one. Niels Bohr made a very important contribution to our understanding of the atomic structure when he came up with what he called the planetary model of the atom. This is what we made our atomic snowflake from. Erwin Schrödinger in 1926 came up with the modern concept of the atom with quantum mechanics. And we still use the shell, the subshell, the atomic orbitals, and stuff like that with his concept of the atom. With his model, we still do the shell. Remember, this is the period that we wrote down on the left-hand side of the periodic table. The subshell is the colors, and the colors represent the S, the P, the D, and the F, and these are the subshells. The orbitals are how many groups of 2, so they can hold 2 electrons, but they have to be opposite spin. We'll talk about that a little bit more in a bit. And then the electron, of course, is just that, an electron. So every electron is shown. Okay, so using our nicely colored picture now, we should be able to quickly grab any element, say rutherfordium, and be able to say that it is in the 4D. We could grab sulfur and say it is in the 3P. We could grab barium and say it is in the 6S. We could grab californium and say it is in the 5F. So you should be able to do that with any element on the periodic table at this point. And this is where we're stopping today, and we'll see you next time.